Let me introduce you to our next tool for learning today. This is the Energy Bike. Now the Energy Bike started out as a regular normal bicycle. You can see it's got wheels, seat. Raise your hand if you like riding a bike. I think almost everybody does because, well, not only is it fun because you can go faster, but it's also really efficient because you use gears and pedals and wheels to make your energy more efficient. You can move farther, faster. Well, this bike has been adapted though. We started as a normal bike, but then we attached this. This is a generator. So now, when you pedal the bike and use your physical and mechanical energy, turns that generator, which then will make electricity. So I want to interrupt myself. I know we were talking about the energy cycle and how it worked, and we were about to get on it. I was going to show you how it worked. But I wanted to take a chance to talk a little bit about electricity, because everything else we've been talking about fits into that category of matter or energy. Now, some things, like air, water, things like the ground, they're solid matter. We can weigh them. They have temperature. They take up space. They have different properties depending on the phase of matter. Some things are hard to detect, like air. It's not very heavy. But energy is not matter. You can't hold it. And electricity is really one of those things because it doesn't have, it's something that acts within the matter. It literally takes parts of atoms, the electrons, the small parts, and moves them around. And when it moves them around in particular ways, we can use that energy. Now the bicycle, that silver box on the end, is from a 1969 Volkswagen Beetle. So it's a generator that creates direct current. This also has a generator in it, that silver cylinder. And rather than getting on the bike right now, I'm going to turn this handle. Now what happens in this is there are some magnets in there. And I'm sure you all know how magnets can grab things. Well, what this does is the magnets in this grab the electrons, push them through those wires. And as it pushes them through those wires, it creates electricity. More energy, quicker I spin, brighter the light. Less energy, slower. Now this is a small generator. That's a small generator. But we get all of our electricity from big generators. Power plants and hydroelectric dams, they have giant generators, bigger than a room, bigger than a house, full of coils of wire. And they use something, the weight of the water, over a turbine. Or they burn coal and create steam that turns a turbine. The turbine is like this generator. These giant machines create lots of energy for us all to use, to provide us with our lives. I'll let us get back to the bike now. Now, we all like electricity. We can do a lot of different cool things with electricity. All this bike will do is light light bulbs. And I have 4 incandescent light bulbs. So I'm going to get on the bike and start riding. And as I start riding, you'll notice, watch my face, watch my breathing, watch to see if I sweat. Because I feel it when I'm pedaling. I'll begin now. Getting his cadence, turn the glass, getting good riding, and now I'll turn on 1 light bulb. 1 light bulb's not too much, about the same energy that a laptop computer uses. I could do this for a while. Now if I wanted to watch TV, I'd have to put this much energy through it. And it's already making my legs have to work hard. Now that's a medium-sized TV. If I wanted to use a desktop or a gaming station, I'd have to do this. And you see, I'm really having to struggle now. It's really not easy. And 4 is like running something small appliance. A lot of different things. As you can see, it takes a lot of energy. Now, I wish that you were here today so you could try to ride the bike. see how much energy that you have. And I'm sure you have more energy than I have because, well, you're younger, hopefully you move more. And, but instead, I'm going to take the energy bike out and go find people to ride the bike. I'm going to ask them a few questions first, though. I'm going to ask them when the last time they rode a bike was, how many minutes a week they spend moving, walking, riding a bike, skating, doing whatever they do. And I want you to make a prediction to see whether or not they will be able to light all 4 lights. So let's go find some people, and then we'll come back. We have our first volunteer. What is your name?
Brendan Davey.
So Brendan, I'm going to ask you 3 questions for our students in the virtual universe. So they have information. Now my first question is, first, do you like riding a bike?
I do. I ride at least once a week, sometimes twice.
So that was my second question. How much time do you spend being physically active, riding your bike, walking, hiking every hours a week maybe?
3 to 4 days a week for maybe 1 to 2 hours each day. Biking, swimming, a little bit of walking and hiking.
Excellent. So my third question for you is how would you rate your general health?
I'd say average to above average. I think I'm pretty healthy and I eat pretty well. Try to take care of myself.
Good. So what we're going to have you do is we're going to have you start riding the bike. Now for the students, I want you all to make a prediction as to whether or not Mr. Davey can light all 4 of these lights. So let's give you a little bit, make your prediction. It's pretty simple, yes, no. What do you think, Brendan? Do you think you'll be able to light all 4 lights?
I'm going for 3.5.
Okay. All right, so go ahead and start riding. You've already got a cadence going. Turn on 1 light bulb. Now, this is about the same amount as a laptop computer. Light a 2nd light bulb. So now, now you're moving into this is a medium-sized TV, maybe all right, 3 light bulbs.
It's getting harder. Oh my goodness.
So 3, this is a desktop computer or a TV with a gaming station. And now, so you can make your refreshing after-time beverage, turn off the
We're going for 4.
4 lights. That's about the same as a blender. So you'd have to do that for a month. So,
finish.
So you were successful. You lit all 4 bulbs. Do you think you'd be able to light them for the minute and a half you'd need to crush ice?
No.
Or with
Possibly.
3, do you think you'd be able to use a game controller while you were...
I could, but maybe not playing the game at the same time.
Well, and you're breathing hard, right?
Heart rate's up. I can feel it.
And what are you exhaling?
Carbon dioxide, lots of it.
You can take your mask off if you want to, since you're going to be riding a bike. Well, thank you for volunteering today. Celebrate your name?
Tim Fox.
So Tim, I'm going to have you ride this bike, and this bike actually generates electricity. But before you start riding it, I'm going to ask you 3 questions. First one is, do you like riding a bike?
I do.
Second question, how often do you ride a bike?
Maybe once every couple of weeks.
Once every couple of weeks?
Yeah.
So third question is, how many hours a week do you think you do exercise? If anything from walking to strenuous stuff?
I would say 2 hours a week.
2 hours a week?
Yeah.
And last question, do you think you're in average health, better than average, less than average?
I think average.
Average health, okay. So before you start riding, I want to ask our virtual audience a simple question. I want you to predict whether you think that Tim will be able to ride the bike and light all 4 bulbs. Give you a chance to think about that. Raise your virtual hands, yes, if you think he'll be able to do it. All right. So Tim, why don't you go ahead and start riding. Get a good cadence going now. Turn on a light bulb. So that's one light bulb, about the same as a laptop computer. Light a second light bulb. 2 light bulbs, the same as a medium-sized TV. How about 3? Now 3 is where you're getting to a gaming station with a TV or a tower computer with a monitor. Now at this point you're probably feeling it, yes?
Yeah.
Alright, let the 4th light bulb. Now at this point you're running that blender that's chopping up the ice to make that refreshing beverage. And you have to do it for 1.5 minutes.
Oh.
Do you think you'd be able to make your crushed ice beverage?
No.
No. You may stop now. So when you turned on each light bulb, what happened?
Got harder.
Got harder. Started out being like a pretty level ride, didn't it?
Yeah.
And by the second one, you're going up a modest hill, maybe. But what about the 4th one?
4th one was hard, like going straight up the hill.
Yeah. Well, thank you for creating some electricity and participating.
Thank you.
So the device in front of you measures the amount of carbon dioxide in the air. And what I'm going to do is when I work, I exhale carbon dioxide. So I'm going to start riding the bike, and I am going to be putting the machine, this tube in my mouth, and I'm going to be exhaling carbon dioxide. And we'll see if the level goes up as I work. And we have a volunteer who's going to be reading the numbers to you. All right, let's go.
Started at 470. $630, $984, $19, $2,059, $2,064, you're staying about 2,064.
So as you can see, while I was riding the bike, I was using energy and exhaling, and I was exhaling carbon dioxide. At about what's in the ambient air, about 0.4%, goes up to about 2% of the air that I exhale as carbon dioxide. Similar thing happens with combustion. When you burn wood or coal or whatever, it creates carbon dioxide. And I get out of breath. All right. So when you ride the energy bike, you use your own energy to create electricity. Usually electricity comes from burning coal, which is a rock, burning natural gas, or nuclear power. All of those have their own set of environmental issues. But the combustion creates air pollution. So when you reduce the amount of electricity you use, it's better for the air. There's less greenhouse gases going into the air. It's also better for your health. And you might save some money. Because when you use less electricity, the power companies don't charge you enough. Or if you have solar panels, you get to save money. Same thing is true with transportation. When you drive more efficient cars, or eliminate driving by carpooling or trip chaining or riding a bike or walking, still, again, it's better for the air and it's better for the environment. I wish you could have ridden the energy bike today, and hopefully in the future you'll be able to do that when I take it out to places like the Arboretum in Asheville or other events. But until that time, I hope that you enjoyed my presentation and have a good day.